Hi, welcome back to another video. Today in this video, we're going to be talking about Venn diagrams, okay? So we're still talking about set theory. And so a Venn diagram is a visual way to represent relationships between sets, okay? So it's a visual and we typically use a rectangle. And the rectangle represents what we call the universal set. So the universal set is just the set of everything that you're talking about. So, for example, I'm going to use the set of U.S. citizens. So say I was talking about the set of all U.S. citizens. So that would be my universal set in this example. That's the set of what I'm talking about. That's the overall set of what I'm talking about. And then within this Venn diagram, so this is our Venn diagram, we have the universal set, and then we have subsets that we represent inside of this rectangle with circles. And so you have many different subsets of the set of U.S. citizens, but just for example, I want to say the set of all females, okay? So I'm going to use one subset and I'm going to call it set A, and set A represents the set of females. And so now you're going to ask yourself, where do I fit in this Venn diagram? So if you're a U.S. citizen, where do you fit? Are you a female? If you're a female, so I myself, I am a female. That means I fit inside that circle. If you are not a female, that means you fit outside of that circle. So you're not in here, which is a set of females. You're out here in the universal set. Well, A is also a part of the universal set. But this, if you're not a female, that means you're in the universal set, but you're not in set A. Okay. So this is an example of using a Venn diagram to represent a universal set of U.S. citizens, and then just one subset of females. You could have come up with different subsets. You could say African Americans, you can say males, you can say children, individuals 18 and under. So there are lots of different subsets you could have represented in this Venn diagram. That was just one example that I showed you. Okay, for this first example, this is a very simple, basic example. We have a Venn diagram that has this universal set, and everything in here represents what's in the universal set. And so if I wanted to just go and list out the elements in U, I will list everything in here. Okay, so actually that's a part of what we're going to do. So we have to do three things. First, we have to find set U and list it out in roster notation. We have to find what's in set A and list it out in roster notation. And then we have to find the elements that are in U but not in A. Okay, so just starting out for part A, if we want to find U and list it in roster notation, that would be everything that's in this whole Venn diagram. So 5, M, $, this square, and this triangle. So all 1, 2, 3, 4, 5 of these elements are in set U. Now for part B, I want to list the elements that are in set A. And A only contains these two elements, which is the square and the triangle. Now for set C, I want to list the elements that are in U but not in A. So in U but not A. So if it's not in A, that means I'm not talking about those elements. So only these elements right here, the 5, the M, and the $. So that's how you would take the elements and list them in roster using the roster method, which is what we did in one of the videos from last week or one of the old videos. You just basically take the elements of the set and list them in roster notation or with the roster method. So that's example 1. Okay, when you use Venn diagrams, you can have a lot of different subsets. And so in the last example, we looked at only one subset. And so this example, we want to talk about all the different possibilities that can happen when you have two subsets, okay? So I have two subsets, A and B. The first thing that can happen, so this is my universal set U again. The first thing that can happen is A and B can share no members. And we call those sets disjoint. Disjoint means that A and B have no members, no elements in common. Those are disjoint sets. They're completely separate. They don't have anything in common. All right. The second thing, or the second case that can happen, is all of A could be inside of B. So this is A, this is B. Again, this is our universal set U. If that's the case, that's what we call, remember, proper subsets. So we write it like this. A is a proper subset of B. That means everything in A is in B, but we know for a fact that A and B do not equal. So this is what your proper subsets would look like. A is completely contained in the set B. All right. The other thing that can happen is A and B can actually equal. And if that's the case, they have the same circle. So A equal B here. Again, this is my universal set, which means there could be things outside in this part. But if A equal B, then they have to be the same circle. All right. And then the fourth thing that can happen is that A and B can actually share some members. So they're not equal, but they do have members in common. And so we actually draw these sets to look like this, A and B, where they overlap. And the shared space is this middle space right here. That's where they share their members. So any members that they have in common will be listed in that inner space right there. All right. So just to make sure y'all can see it, I zoomed in on it a little bit. So here is the shared space. So these are the 4 different things that can happen whenever you have 2 subsets. You can have one of these scenarios. So let's look at an example. For this example, example 2, so we have a Venn diagram. It has 2 sets. I forgot to label these. This is A, this is B. So A has A, B, C, and D in it, and B has D and E, and then out here that's in neither one of those sets is F and G. And we have to actually go through and list the different things, 5 different things in roster method, okay? So the first thing we want to do is list everything that's in the universal set. So the universal set includes everything. So we have A, B, C, D, E, F, and G. That's everything that's in our set. So we'll list that out. A, B, C, D, E, F, G. I'm going to go over a little bit because I'm out of space. And that is our universal set. So A, B, C, D, E, F, and G. That's everything in our universal set. And so now we want to list the things that are in B. So B has E, but B also has this in this shared space right here. That's D. So B has D and E. So that is the elements that are in B. Now for C, we want to list the things that are in A, but not in B. So A has A, B, and C, but it also has D, but D is also in B. So we wouldn't list the D. We will only list the A, the B, and the C, because that is what they have in, that is what A have that B doesn't have. Okay. And then for D, it says the things that are in U, but not in B. So that means we would include everything except these 2 things that are in B, which is D and E. So we would include the A, the B, the C, and the F and the G, because those are also in U. And then the last thing says we want the things that are in both A and B, and that is this overlapping region right here, which is the D. So the only thing in both A and B is D. Okay, so it's important that you know how to read these Venn diagrams. So remember, if the sets are drawn like this to where they overlap each other, then the things that are placed in the middle are the things that are in both sets. That's the most important part that you need to remember for this Venn diagram. Everything is kind of straightforward because you have A, B, and C. They're clearly in A. E is clearly in B, and F and G is in U, but they're not in A and B. Okay, so you need to know how to read the Venn diagrams. So I have a definition for you. I'm always talking with my hands. I know, it's a habit. So I have a definition for you, and it is the complement of a set A. So the complement of a set A are all the elements that are in the universal set that are not in set A. Okay, so basically we call it A not sometimes because that means it's not in A, and we write it like this: A with a line on top, which is in science a lot is said to be prime, also in math as well. It looks like A prime, but this means the complement of A, and this is the formal definition is it's the set of all X such that X is in the universal set and X is not in A. All right, so that's the formal definition of the complement of A. It's the set of all elements X such that X is in the universal set and X is not in A. Okay, so let's look at an example of how to use the complement. For example 3, we have this set U that has 1, 2, 3, 4, 5, 6, 7, 8, and 9 in it. And we have this set A, which has 1, 3, 4, and 7 in it. And we want to find a complement. That means the set of things that are in U that are not in A. So one way you could do is you could just go through U and mark out all the things that are in A. So A has 1, A has 3, A has 4, and A has 7. So that means A complement would be all the things that are left. 2, 5, 6, 8, and 9. So that's the complement of A. That's all the things that are in U but not in A. Okay? If you have any questions about the complement or about the Venn diagram, then please don't hesitate to put it in the comments or send me an email, and I'll get back to you as soon as I get the notification. And that's all I have for this video about Venn diagrams and complements. So make sure you go on to watch the next video, which is about intersection and union of sets. And if you haven't already, make sure you hit that subscribe. I can't even talk. That subscribe button. Thanks for tuning in, and I'll see you in the next video.